again. I know we were all getting kind of
don't worry.
So, a few housekeeping things. Just wanted to remind folks, I see a few new faces in here. If you need the Wi-Fi, it's the Mason network. And then you'll see you can log in for an account. When you do that, create an account. It gives you a PIN real quick, and then you're on the Wi-Fi all day. Okay? Other thing is, too, is all of you attending, we are having a happy hour at 4:30. We will have speakers there, so in case you have another burning question that you just couldn't remember right after the talk, or we'll go right into the next one, please come with your questions, meet fellow attendees. It's a great way to meet people in the community. Other than that, up next, we have a real special guest. Baruch is here with us from Nashville. I don't want to steal his thunder, but he's going to be talking to us today about developer productivity.
Yes.
It's one of his burning passions in life. And what's great about Baruch is you can always find him at a conference because he wears this fun hat.
Yeah, that's the idea.
So Baruch, I'll let you take it away.
Thank you very much. Thank you, good. All right. Yeah, we're going to talk a little bit about DevOps, but also developer productivity, and see how those two are related or unrelated. I'll start with the conspiracy theory. I hope we will land somewhere here in the yellow. The good news, I have proof that my conspiracy theory is actually correct, so it's fine. And the conspiracy theory goes as follows. DevOps is a conspiracy by ops people to make the developers do their job. How many of you are developers? Any ops people? Yeah, a little bit, couple of. Okay, all right. So it's going to be fun. Yeah. So my name is Baruch Salgurski. I'm at jbaruch on whatever Twitter, X, Blue Sky, Mastodon, whatever, everywhere. Developer productivity advocate. Also developer relations advisor with the company called Gradle. You might know about it if you are in the JVM ecosystem from the build tool, obviously. As of today, the most used build tool in the JVM ecosystem. But generally, Gradle is more than that. It's really a developer productivity company, right? They have another tool called the Velocity, which is developer productivity engineering implementation. We're going to talk a little bit about developer productivity engineering and what it is and how it is done. My background is I started as Java developer many years ago, and then went to the DevOps space with another company that you might have heard about called JFrog, and now talking about developer productivity in general and developer productivity engineering in particular, for which we have a hashtag DPE. Surprisingly, 3-letter hashtag there was not to overcome with other stuff on social media, so now it stands for developer productivity engineering, whatever it was prior to that. I co-authored a couple of books very relevant to the topic. The first is DevOps Tools for Java Developers, speaking to my both Java and DevOps background, and the Liquid Software, and that's a book about a vision of how we should all release software. So the most important slide of this talk is this one. If you go to speaking.jbaruch, you will find there a page dedicated to this talk at this conference. You can click on it, and you will find the slides that are already there, the video that I'm recording and the organizers are recording. Hopefully one of them will get recorded because technology is hard. And all the links for everything, including the books and everything else, is already there. To make it easier for you to remember where to find it, it's on the bottom of every slide. Right here, speaking.jbaruch, together with hashtag DPE at DevIgnition. When you praise this talk, use the hashtag and the handle and at jbaruch. All right. So back to my conspiracy theory, right? As I said, I'm a developer, but I also been a lot in the DevOps space. So I think I recognized this conspiracy of ops people against us, the developers. Right, and I say it in a lot of places. The most, I would say, obvious one is this. The Phoenix project is, I would say, the most important, if not the most important, the really one book that you should read about DevOps if you didn't and you want to understand what DevOps is. Who heard about the Phoenix project, read it? A lot of people, great. It is an awesome, absolutely awesome book. Whoever didn't, I really recommend it. It's a novel, so it's very light reading. And it's a novel about a protagonist and an engineer who kind of invents DevOps and transforms their company, turns it around from going down the drain to be a very successful company using DevOps. That's kind of the premise. All we need to, for our conspiracy theory proof, all we need to do is look at the cover, because the cover conveniently shows all the main characters in the book, and I want to show you who they are. Right, so we'll start right there. It's a little bit small, I'll read it out. Patty, she's the director of IT service support. She is an IT person. And then there is Wes, who is director of distributed technology ops. Is obviously an ops person. And then Sarah, she's like the main antagonist. Obviously, she's in sales. And then there is Steve, who is the CEO, and he was kind of on the fence. And then there is Dick, who is the CFO. Fine. Here's the main protagonist, Bill Palmer, and he is a VP of IT Ops. He's like the ops guy of the entire company. Eric, he's a board member, and he's the one who actually gives Bill clues that pushes him towards DevOps. Those clues, by the way, are all based on another book called The Goal by Eliyahu Goldratt. And funny enough, Goal is exactly the same idea. It's also a novel about a person who invents a way to do business and transfers their company, which is, there is some nice recursive irony there, but it's like off topic. Yeah, so Eric is one of the directors. Brent, lead sysadmin, obviously, ops guy, and there is a security guy hiding there because everybody beat him, and okay, that's a terrible story. Never mind. So yeah, any observations? What do you see or don't see? Developers. Where are the developers? Right? It's a book about DevOps. Dev should be somewhere there, but there is none. Well, there are developers in the book, and they're not pictured in a very nice light. We'll get to that in a second. Let's see another proof. Very profound as well. So when you type in Google, what is DevOps? Who is teaching us what DevOps is? We can see, so there is Amazon, which is obviously an ops platform, Atlassian, a DevOps company, GitLab, another DevOps company, Microsoft, another ops platform, TechTarget journalists, Wikipedia, Synopsys, ops observability stuff, Logs.io, ops observability stuff, and there is IBM down there trying to be ops company. It's all ops people who are pushing this DevOps thing very, very hard. So it's really kind of an ops thingy. And the real question is why? Why it's suddenly so important for ops people to sell us, the developers, the idea of DevOps. So you start to look like, okay, what this DevOps thing is. And here's a funny question on Quora, not the best of sources, but this one was very profound. As a Linux system administrator, how do I shift my career to DevOps? And then Disha, who is apparently DevOps online trainer for many years, goes about, hey, all you need to do, you're already a sysadmin, so you already know the Linux administration, which is great. And then all you need to do is learn some tools. Chef, Maven, Jenkins, something that's called Gits. And the next thing you know, you are a DevOps engineer. How cool is that? And the good thing of moving from being a Linux system administrator to being a DevOps engineer is that this is what you used to earn, and this is what you're going to earn now. Just by being a Linux system administrator, you learn Gits. How cool is that? And then it's like a snowball. It's rolling down there, and next thing you know, there is even now, with all the economy downturn and like massive layoffs and what's not, 20,000 open positions for DevOps engineers in the United States alone. It is a big deal. And then obviously the next thing you know, hey, remember Amazon that tried to sell you DevOps? Now they're not only selling you the idea, they actually sell you certifications to being DevOps engineer. Basically, they teach you Linux administration and Git and their own stuff over there, right? And boom, there is an entire industry of system administrators who are now DevOps engineers. And I don't take it well. We're gonna get back to the entire thing of DevOps engineers and how stupid it is. But before we get there, I don't think that the answer, hey, all the DevOps thing is for the money, is the right answer. We need to go deeper and ask why again. And as you know, if you ask why enough times, you'll be promoted to engineering manager. So we will stop at 2. We will ask why once again. And here's my take. They are not wrong. Right? I mean, developers see, a lot of developers see their work as in a pretty limited scope. Right? And this is writing code. And once writing code is done, the developers are kind of done. And the ops people left with the hard part of deployment, all the stuff that developers wrote, and the developers are there for that. So the drive of ops people to pull developers into the fold and kind of say, hey, we're in it together. We need to work together to deploy our software, and this is what DevOps is about, actually makes a lot of sense. So yes, I mean, it's clearly proven by me that DevOps is an ops conspiracy to make the developers work harder. But it is actually for a good reason, and they are right. Developers really need to participate, and we need to be in charge of the software that we write and make sure that it is deployable easily and be there when the things go bump at night at 3 a.m. because our software had a bug. It's still our responsibility. So generally, yeah, they have a point, right? We really need to be there. The problem is, we don't really want to. Because it is on-call at 3 a.m. We don't want to do on-call at 3 a.m. Right? I mean, it's still not very appealing to us, the developers, and basically we are not convinced. And we have our own good, very good reasons not to be convinced, and this is what we're going to talk about next. So, funny story. Among all the GIFs, not GIFs, GIFs in the internet, I couldn't find a single one that goes from sad to happy face. There are a lot that go from happy to sad for good reasons that we won't mention today of all days, never mind. So I had to take a happy to sad GIF and reverse it to get this. But yeah, so how do we get from us the developers not being very excited about DevOps to be very excited about DevOps? How do we do that? Let's go back to the whole crap of DevOps engineers. So, DevOps engineer is not a thing. DevOps engineer is not a thing because it doesn't make any sense. DevOps engineer makes as much sense as collaboration engineer because DevOps is a collaborative practice that promotes collaboration between two different types of engineers, the developers and ops. Collaboration engineer is not a thing, and DevOps engineer is not a thing. And the reason why I'm so upset about it, people like let it go, who cares? I do care because naming things incentivizes behavior. And when you have a lot of DevOps engineers, you know what happens next? You will have a DevOps team. And this is how you might envision DevOps team, But this is what actually DevOps team is. So I'll read it out right here. It's a dystopian TV show about how in a ruined and toxic world, thousands live in a giant silo. This is a DevOps team. DevOps team is just a new silo. And the entire idea of DevOps is to bring down the silos, the dev and the ops, and bring them together. But what we did by introducing DevOps engineers is build a new silo. So now DevOps engineers live in a silo, and developers live in another silo. And our next frontier is let's break those silos down. And you know what? Next thing we know, we will have DevDevOps. DevDevOps is a collaborative practice that makes developers and DevOps engineers work together. So it is that stupid, and obviously DevOps engineer is not a thing. Now, jokes aside, there is engineering aspect of DevOps, right? So there is like a lot of technology that appeared in the last 15 to 20 years that requires engineering. This engineering is not DevOps engineering. Back in like 10 years ago, Liz from Jones and Seth Vargo explained to us, working both in Google, that the engineering aspect of DevOps called SRE, Site Reliability Engineers. Google came up with the term, and you might think that Google really should do better in naming things, because they're Google. The problem is, no one wants to be a site reliability engineer. When I worked in JFrog, and I had this crusade against DevOps engineers and DevOps teams, JFrog actively hired for DevOps engineers. And it obviously pissed me off a lot. And I went to like the hiring manager, and I'm like, what the actual heck? Why do we hire DevOps engineers? DevOps engineers do not exist, it's all blah, 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 blah. And he told me, no one wants to be site reliability engineer. We tried it. No one wants to. And I'm like, why? And he's like, they're telling us they want more than just maintain the uptime of our website. And I'm like, what? And he's like, yeah, this is what people hear. When they hear site reliability engineer, they think about website. They think about that their work will be make sure that our WordPress is up. And I'm like, no, this site is everything, it's service. And he's like, I know, but they don't. The ads for site reliability engineers perform really poor. So you might think that Google would do a better job. I have good news for you. We have a new name for the engineering aspect of DevOps, and it is platform engineer. It was intended to be something completely different, but as with SRE, it was completely misunderstood, but this time for good. Scott Shaw, I saw him speaking at the DevOps talks in Australia, like I think it was a year ago, and he was talking about how DevOps engineers are rebranding themselves to platform engineers. And I'm like, yeah, finally, great, perfect. Okay, everybody wants to be a platform engineer. This is the next big hype today after AI, obviously. And it's good. I, for one, really embrace the thing. And if you look at the internet and ask what is the difference between platform engineering and DevOps, you will see people like, okay, platform engineering is the next step of DevOps evolution. Fine. DevOps teams create software focus. I mean, everybody are talking about how this is the next thing in DevOps, and I, for one, I'm very happy about that. There is like tons of results that talk about how DevOps and platform engineering are related, are the same, are the next thing. And then I went and asked ChatGPT, what is it? And ChatGPT was like, hey, platform engineering is about building and managing scalable infrastructure and services that enable developers to efficiently deploy and run applications. Thank you very much. This is what you call today DevOps engineering. So it's basically someone who writes all the YAML files in the organization. Yes, it is. Perfect. Great. That's exactly what we wanted. So platform engineer is the SRE, is the DevOps engineer. Great. With that last transformation and the last piece, I'm in peace with DevOps. Done. DevOps is, we figured it out. Now, I'm not saying that everybody's doing DevOps. I'm not saying there are no DevOps teams around, or that every DevOps engineers understood their wrongness or their title and rebranded themselves. I'm not saying any of that. What I'm saying is that if there is an organization that wants to do DevOps correctly, they know how to do it. They know where to find the information. They know how to find the people. They know how to train those people. They know what those people need to do. All the solutions of how to do DevOps are there. And you know what? Still, us the developers are not really excited to be on board. Let's see why. So the way we used to talk about DevOps is, well, this is Venn diagram because everything is explained in Venn diagrams, and we have Dev and Ops because that's the name DevOps, and then, oh yeah, by the way, also QA. What? What? It doesn't help. What does it say? Are there people who needs to do all of that? Is there like what? And they're like, okay, this is not gonna help you. Let's try something else. How about it's something that happens between people when they work in some process and there are some tools involved and this DevOps like magic happens. Well, this is better, but what do we really mean? And here we can start actually articulating that we care that people who work productively within productive process and using productive tools are actually are able to deliver software faster, in better quality, more consistently, with less failures to production. This is the goal of DevOps. This is what we do. And now, in the last 15 to 20 years, we started to figure out what this actually means. So we know now exactly what productive teams are. Productive teams are empowered teams in which developers, ops people, quality people, security people, product people, all of them come together and work together as a team to create software. Fine. We kind of figured out productive tools, more or less. You can call Kubernetes that. It's okay. But what about productive people? Now, how do we make people more productive? Now, you might say, well, people are as productive as they want to be, but this is not really the case. There are widespread pains that slow down people in general, and developers in particular, from being productive. One of the most painful examples is build time, right? Builds and tests are slow. How many of you, you're all developers, have a build which is faster than 10 minutes with tests, like the entire thing? Okay, that's really sad, like 3 people. Okay, the rest of you have built slower than? Okay, let's start. Faster than 20 minutes? Okay, so most of you are there. Faster than 15 minutes? Okay, faster than 10, that's the 3 people. Faster than 5? Not really. Oh my God, this is that bad. So you're definitely in this 90%, right? No one thinks that 20 minutes build is fine, right? You agree with me? It really should be 2 minutes, no more. And it should be no more than 2 minutes, because I'm going to talk about why. It's not only that, there are other pains. So that's your build or CI and test, but also inability to troubleshoot and determine the root cause of failures, right? Your build failed. You have no idea why. You have vaguely idea maybe who to blame, but it really doesn't help. And then obviously performance regressions. Okay, you fixed your build, now it's fine, but in 2 months it's slow again. Why? You don't know. So this is just some examples that prevent you as people, as engineers, to be productive. And for me, the next frontier is the production system of your production system, which is your development environment. And one of the things of making people productive is the developer productivity engineering, the DPE that we are talking about. What is developer productivity engineering? It's basically a bunch of ideas that will help you engineer productivity into your developer work. Stuff like foster, faster feedback. We're going right into the build problem, right? The feedback that you have on your local build is not fast enough. Now, why it is a problem? It is a problem because build should be synchronous feedback. You write some code, you run the build, you wait for it, you fix the code, and this is your feedback cycle. If it's slow, you do one of two things. You either don't wait for it, and then you context switch, and it's really bad for tons of different reasons, or you just kind of give it up and let it run on CI, which is asynchronous feedback. You don't need to wait for CI, but then you cannot really concentrate on anything else because you have zero confidence in whether your code will pass or not. So either way, it's bad. Faster feedback is a very, very important tenet of a developer productivity engineering. Toil, stuff like how much stuff you need to do in order to get to what you really need to do. All those useless ceremonies around code that really need to go away. Friction will disturb your focus and will hurt your productivity. Effective tuning. We spoke about, hey, my build is failing and I think it's the other guy's fault. What do we do now? We can dump the entire output of the build on them. I don't think they're going to be happy or help you with that. If you can send them the exact root cause of the failure, they might want to help you because this is effective collaboration. Prioritize automation and eliminate bottlenecks. This is straight from DevOps handbook. This is what DevOps is about for your production systems. When we build those pipelines to production, this is what we do. We automate and we eliminate bottlenecks. But what about for our development environment? Do we do that as well? We don't and we should. Observability, another kind of a big thing with DevOps. All of us have complete observability on our production environment because in some point of time we decided that waiting for users complaining on Twitter about our software not working is not a great way to get feedback. So instead, we build observability for our production environments, and great for us. But how about our development environments? Do we really know what's going on when we run those builds and those CI and CD pipelines? We probably not, and we really should. Organizational mindset is something that all this stuff should start with. Me fixing my own local build is nice, but what I really need is my organization to take initiative to move forward with developer productivity engineering and take it as organizational mindset. And outcomes over output, which is also very important. Remember the entire dump of the build that I mentioned? This is output. This is noise. We need to find the outcomes only and concentrate on that. Now, the good news is that if organizations really put their minds on it, the results are amazing, significant, and pretty fast. 84% of organizations that agree that since integrating development engineering into our development process, the time savings to experience on the build and test cycle times have dramatically improved developer productivity. This thing really works. And I guess the same 84% said something else that made me very excited about developer productivity engineering. Developer productivity engineering fosters developer joy. Remember how show notes, this is the most important slide of this talk? This is the second more important slide of this talk because it has the word joy on it. No, really, I mean, we all want to have joy. And if developer productivity engineering does joy to 84% of the survey takers, we really should do it. Now you sit here and some of you just walk out because, fuck it, developer productivity engineering is not my job. I want to write code. Well, that looks familiar. DevOps also is your job, right? And somehow we spoke about how it really should be. It's exactly the same idea with developer productivity engineering. The outcome of DevOps transformation is the product itself, right? We're talking about production systems, we're talking about our Kubernetes clusters, and obviously this is why DevOps takes precedence. The outcome of developer productivity engineering is more productive work. So the urgency of DevOps is on everybody's mind because this is about product. This is the company transformation that helps you develop faster, deploy better product in a more stable way. So this is on everybody's mind. Now, developer productivity engineering, yes, it's very important, we just spoke about it, but it tends to slip away because how many of you think about, hey, my build is slow daily? No, not much. I mean, I just made you to think about it and it will be on your mind hopefully today, tomorrow, but in a week from now, maybe less. It does slip away. This has direct effect on organizational structure. We don't need DevOps teams because DevOps is an organizational culture. But we do need specialized developer productivity engineering team to make sure that it is an organizational mindset. And the best organizations, those who report joint stuff, they build focused teams. For example, Snowflake hiring for developer productivity engineering manager. And LinkedIn hires for productivity and IT group. And Microsoft hires for platforms and engineering productivity group. And Spotify writes blog posts about how developer productivity improved their entire thing, right? And Netflix hires for senior developer productivity engineer, and Elastic hires for engineering productivity, etc., etc. So you understand the thing. DevOps engineers and DevOps teams are not a thing. Developer productivity engineering teams are very much a thing. And I'm going to mention a DPE Summit in a second. All of them speak about, at DPE Summit, about how their teams are making sure that DPE is that organizational mindset that it's not. So we're talking here about evolutionary process, about how we started with the silos, how we are fixing our production with the DevOps culture, and the next thing is fixing the people productivity with developer productivity engineering, right? So, I mean, DevOps solves ops concerns. That's a fact proven by like book cover. I mean, what else do you need? And it is a collaborative methodology. It requires engineering and whatever it's called, site reliability engineering, platform engineering, YAML engineering. Someone has to write these YAML files, fine. But what about people productivity, production systems of your production systems? This is where developer productivity engineering comes into play, and this is your another pillar of DevOps. So you can learn more and try it today. If you go to speaking.jbaruk, you'll find there a link to what we call a speed challenge. It's basically, we take your build or any open source build that you want to try and play with, and then you do a couple of stuff, and then it's significantly faster. And you're like, oh, that wasn't that hard. I need to do it for my build and the build of my team. And you get awesome swag in a way. So that's your speed challenge. Talk about DPE in your organization. Hopefully it will help raise the awareness that we spoke about. a DP handbook, more of what I just said in an ebook format, is also at speaking.jbaruch, and the DP summit that I wanted to bring. It happened in September. We're still waiting on the videos to be published. The keynotes are already published, so you can watch at least those for now. And with that, thank you very much. I'm at JBaruch everywhere. This is DevIgnition. Speaking.jbaruch is where you find the slides, the video, and all the links to everything that we spoke about. Thank you.
Thank you, Baruch. Okay, let's give a round of applause. So we're going to have Ryan Kuprek come up next. But while he is getting ready, I think we have time for a question.
Perfect.
So anybody have a question? And that was, by the way, that was hilarious. So
Thank you.
totally got me interested from the beginning, and I might be a conspiracy theorist now.
Yes.
So it was pretty well put together. But any questions do we have from the audience? I know that was a lot of ground to cover. And we do have some ops people in here, so I would imagine some people might have questions. No takers.
We have coffee to drink, so that's absolutely
Alright.
fine.
Alright. Well, he'll still be around,
Yeah.
probably at the happy hour too, so if you have a question and you want to ask him one off,
Absolutely.
please feel free to do that.
Thank you.
Thanks, Baruch. So up next, we've got Ryan Kuprek. Am I saying that correctly? I hope so. Kuprek. Close. But I believe you're the president of the Java user group in Connecticut. Is that correct? Awesome. So we're having a lot of big people in Java today. This is very exciting for the Mid-Atlantic. But yep. So I'm going to let Ryan set up, but up next is Jakarta EE 11 and beyond.
Hello, can you hear me? Okay, great. Yes, welcome to Jakarta EE 11 and beyond. I'm Ryan Kuprek. My contact information is up there. I work for Dassault Systems on chemical formulation software. I've been using Jakarta EE, Java EE for a long time now, many years. And I'm heavily involved in the Jakarta EE ambassadors, which I'll mention as I go through the presentation. So Jakarta EE 11. So first, Jakarta EE, as I assume everyone's aware, was rebranded a couple of years ago. Back in September of 2017, Oracle announced that they were donating or transitioning Java EE over to the Eclipse Foundation, which was actually great news for the community because it got it out of, basically opened it up to the community, enabling the community to drive the development of the platform and determine its direction. So 2017, the process was started. By 2019, the first version, Jakarta EE 8, which was just a rebranding of Java EE 8, was released. The name change was due to Oracle not donating the name Java with it, so that is why it transitioned over and became Jakarta, the Jakarta name, which was donated from the Apache Foundation. So it has an open governance, open source, open compatibility testing. Previously, the compatibility testing was something that you had to pay for. That is now open. You can actually download and run compatibility test yourself to verify conformance and even contribute to it. So it has a well-defined specification process for IP flow. Key stakeholders are still involved, including Oracle, IBM, and then there's been new ones. So there's VM, London Java Users Group, Omnifish, Java, Hire, etc. So the community, the previous companies that were involved continue to be involved, and we now have brought in new participants into it, and more so from the Java user group level as well. So it's moving along quite nicely. The link at the bottom is for the main Jakarta EE websites to get more information on it. Now, Jakarta EE is extremely important to the Java community, whether you realize it or not. Most Java developers, even if they don't consider themselves Jakarta EE developers. I think in the past there's been a lot of people, a lot of developers assume that in order to be a Java EE or Jakarta EE, you're writing a monolith and applying it to a container. That's not true. If you're processing JSON in Java, if you're using Hibernate, using any of those technologies, you're using something from Java EE, Jakarta EE. So really, your resume, if you look at most Java resumes out there, they are full of Jakarta EE terms, JPA, JMS, JSF, you name it, most of the acronyms out there come from, any of the acronyms out there on a Java developer's resume come from Jakarta EE. So it's in our vested interest to make sure that this pushes forward and continues to drive innovation, because it's really key to the Java platform. The survey was actually just released recently, the developer survey for 2024. So we have a breakdown in terms of different technologies that are out there. So Jakarta EE Spring Boot does use Jakarta EE technology. So although that's usually viewed as kind of a technology, it does use and does contribute to the Jakarta EE platform. It uses technologies, it's not completely self-standard. So this cross-pollination between the two of them and also microprofile. As you can see, the usage of it over just the past year has increased. 25 to 35% of Java applications run on an EE container. That's running a monolithic container. 70 to 80% of the Java applications that are out there, I think it actually probably higher, use at least one of the Jakarta EE APIs. Unless you're doing a straight desktop application, you're probably using one of the Java Jakarta EE APIs for processing JSON, for making a RESTful web service call. All of that comes from Jakarta EE. And sometimes it's actually surprising how small the team that actually makes all of the technologies that we use, how few people are actually involved in making those decisions and implementing them. It's really surprising. Now, Java EE, Jakarta EE has been around for over 20 years now. So it's not possible for somebody to have been born and be using Java EE today when it came out before they were born. And although that sounds bad for technology, when you realize that Python and some of the other current hot technologies are actually getting older than this, kind of puts it into perspective. So Java EE originally came out as the Java Professionals Edition around 1999. J2EE came out. And although you'll still see people referring to J2EE, that term hasn't been used in probably over 15 years. Hopefully the AI systems, because I still hear lots of people using them, hopefully the AI systems that are processing resumes have picked up on that. And so they're not, you'll see a requirement, must be acknowledging J2EE, and it's like nobody's used that term in like 15 years, or 20 years now actually. So it's really funny how some of these older technologies, the thing gets renamed or something like that, you run into somebody and they still think it's J2EE. That's what the perspective of it is. So it's evolved over the last, over 25 years now. So Jakarta EE 11 is coming out hopefully next month for the Jakarta 1 stream. So Jakarta EE 8 was the rebranding of Java EE 8. Jakarta EE 9 was primarily for containers that was the first release on the new namespace, because the namespace was implemented by Oracle either, so it had to be a new namespace. So that was done in Jakarta EE 9. So Jakarta EE 10 was the first release with new features to kind of entice developers to go from EE 8 to Jakarta EE 10. And also, upgraded Java. Besides that, so right now we're closing in on release of Jakarta EE 11, and Jakarta EE 12 is development and discussions of that are now started. So part of this presentation will be devoted to just talking about what could possibly go into Jakarta EE 12, and there's some exciting things that could go in there. This is a graphic from InfoQ, kind of dividing up the community. So you have your late majority right now, which a lot of developers and companies out there are still on Java EE 8 and Java 8. Amazing sometimes is how many, since this has been around so long, there's still a lot of applications on EE 8. Most have right now either transitioned to EE 8 or Jakarta EE 9. So it's been heavy uptake now, especially it's been driven by the rapid cadence or the rapid release of Java versions. So that's kind of driving some of the migration forward, is that you're on EE8 and you need to get to a newer version of Java, so then you upgrade the version of Java that you must. That's kind of helping drive some of it. Which are EE10, and so that's what's going on with media. But I'm heavily involved with the Jakarta EE Ambassadors, which is a grassroots organization. We were initially founded to push Jakarta EE forward, so we help onboard developers in terms of guiding them, guiding their contributions into the DevOps Foundation. How do you get involved? How do you get to the platform, etc. So to check us out, we have a guide which is going to be updated soon. We're contributing to Jakarta EE 12, and the ideas and what can go in there. So that will be updated on the WordPress site in the next couple of weeks with that. Now moving on, so Jakarta EE 10 was the first release since EE 8 that introduced the features. So several key things made it into it. So we, of course, got CDI continues to expand and will eventually overtake and replace everything that old enterprise Java beans provided. It's kind of unifying the platform. So asynchronous was finally made it in. There's better CDI support in batch, as well as REST didn't make it until 11. Java SE alignment, so there's completion stage and concurrency. There was finally Bootstrap APIs for REST made it in. And then finally closing the standardizations, the app OpenID Connect made it into EE10, along with the managed executor definitions, SQL support. And then finally, that release also began the process of removing some older technologies that not as many developers still use, such as EJB entity beans, which hopefully no one's used in the last 20 years, the embeddable EJB container, and deprecating some of the older feature things from serverless bases and CDI that are no longer used. Innovation continues, which didn't make it into the final release. But there's continued innovation on some projects, NoSQL, MVC, Jakarta configuration, and also gRPC, which will hopefully be making it in. Some of these will hopefully make it into Jakarta EE 12. So Jakarta EE 11 is what you're here for. Finally, CDI now has support for the scheduler. Also, there were changes, upgrades to persistence and concurrency, which are some of the major changes. SE alignment, adapting to Java records finally, adding support for virtual threads, which was added, which is one of the major new features in the Java. And we're continuing on, better integrating CDI into REST that can make it into the final release, also modernizing some of the TCKs. Actually, the delay right now in releasing Jakarta EE 11 was in part to upgrade the TCKs away from Apache Advanced to Maven. Also closing the standardization gap in the in-memory identity stores. And Jakarta EE 11 continued the process of removing stuff from the platform that many developers aren't using anymore, such as SOAP, JAXB, XML, Corba, and managed beans, which is becoming a new Cobra. And then continued innovation on, continued on NoSQL, MVC configuration, and gRPC. So the themes for Jakarta EE 11 was the release. So the release is going to be hopefully within next month. 1721 is now the baseline for this release. So that means that it's Java 17 and greater. So with this release, support was added for records, virtual threads. The platform also had to contend with a security manager, which was deprecated in Java. This is going to have this is one of those changes coming to JDK that's going to have a big impact on the community. So Jakarta EE was out ahead of this. With this release, the security manager has been removed from it. In fact, I think it was just announced that the next version of Java will actually have the security manager removed. So, and there's lots of code out there that's still dependent on that. That will be impacted by that. So there's specifications updates with the persistence, concurrency, security the CDI validation, which I'll get into. We have the new specification for data, which was added, and as I mentioned, XML enclosure removed. So this is a list of the specs. The ones that are in blue are the ones that were updated. The orange one is the first new specification in a while that we've added to Jakarta EE. Many of these changes were fairly minor. But data was the first new specification added in a while. And the thing to remember with Jakarta EE is that it is a standard, so it's after things have been percolated for a while that something gets standardized with the platform. So the idea is that you can end up with multiple implementations, and the industry is kind of coalesced around a way of doing things. Like it's time, when we get to a certain point that we want to standardize. So Jakarta Persistence 3.2. This specification had probably the biggest set of changes to it. Every changes out there with the exception of data. So it added support finally for records as embeddable classes. Finally, support for instance year. So replacing the Java util date, which hopefully nobody's still using. That's kind of hard to get out of. New date dot get time. I think I see everywhere when somebody's trying to almost monitor code or something like that. It deprecated the use of date that previous Java util Java SQL time that I always run into. Timestamp and temporal in favor of the datetime API. Added more SQL-like features in the query language and the tier API. Also added support for a thread safe entity management object, which enables its use more in CDI, and added finally a programmatic configuration alternative for persistence of XML, so you can programmatically configure persistence management. Going into the future, there's discussion, this is where Jakarta 12 comes in, about making persistence XML an optional entry marker file so that you don't have to have it. And then adding JCache as a second level cache provider. So if that's something that should be added, definitely involved with that. Just a short example here demoing embeddable records. As you can see, this is a Java record class. Now you can use this as embeddable. There's different ways of also using it with ID and primary keys. This is an example of using the new programmatic configuration of the persistence configuration. So what you would previously do in that persistence XML, now you can actually do that code. And then there were some improvements in the methods, for example, for being able to create the schema, being able to clear out the database. So, if you have all of your entities and you want to quickly generate the database as part of your tests, this is an option. There's improvements with transactions. So as you can see, you're running some code in the transaction. Much better way of doing things. And then, as I mentioned, the ability to inject the entity manager, which opens up newer opportunities in CDI, improves interaction with CDI, so now it's not going to be done in a type-safe way, and it pairs very well with the transactional attribute of CDI. Part of validation just had minor changes. It now supports validation of Java records. Validators under the Java records classes. Jakarta concurrency. As I mentioned before, it has that scheduled annotation was added. Previously, if you wanted to do scheduling and stay within the platform, you would have used Enterprise Java B and added the scheduled annotation. Now you can do it with just the Jakarta concurrency. Framework. Integration with Jakarta Java 9 flows and reactive streams. As a resource, and the big one is support for virtual threads, which is more of a framework level type thing, but you do have the option of specifying virtual threads. For future Jakarta 12, discussions about EJB equivalent of block, finally getting that into CDI with the concurrency, and also adding mass concurrency. So there's a few things that hopefully will be added to 12. So schedule and CDI being very straightforward. The only caveat with it right now that I don't like is that you have to call a method at least once to get it scheduled. So you end up with this kind of like boilerplate code that if it's a normal call, if it's a normal or the first call, then just return. If not, then after that, then that's a scheduled method. Within the manage executor definition, there's a property that allows you to set true, which means that you want to use the newer Java platform virtual threads. So that's enables better scalability. And then an example that I put together, we do Java 9 reactive stream support. So you can see here the code to read, but it's using the example of using reactive streams in Jakarta EE within Jakarta EE 11. For Jakarta security, there's some basic API changes for handling multiple authentication mechanisms, support for qualifiers, in-memory identity store. And then there's this work that's going on right now with JWT alignment with the micro profile bridge specification. So this is marrying the JWT and the Jakarta security kind of together. So it's a bridge specification between the two of them. The Jakarta micro profile bridge did not make it in the last chapter 7, but that will be coming. And then going forward, we're hoping Jakarta EE 12 later to get finally the roles allowed and run as added to it, so we don't use these for that. And this is an example of an in-memory identity store with an annotation. This makes testing and prototyping much easier, less stuff that we actually have to set up. With Jakarta data, this is the newest specification that was added. This is a higher level repository data abstraction like Spring data or Spring data that automatically generates the repository implementation for you based upon an annotated interface. And it works with both Jakarta persistence, aka JPA, Hibernate, as well as the NoSQL implementation. So you can use this to generate basic CRUD find repository for data for both SQL databases as well as NoSQL databases. So those would be Neo4j, CouchDB, etc. So it works with both of them. So within the basic concepts within Jakarta data are the entity which represents the data, and then the repository which defines the operations related to the entities. So this is a simple example here. So above we have our entity, and this could be a NoSQL or a JPA one-way stored in a relational database. And then our repository, which is going to provide our basic CRUD operations for the application. So it's defining that we have a basic CRUD and provide methods in its annotation base, and then you can inject this into your code. So this saves you from the problem of writing boilerplate code to do the basic CRUD operations, right? So I always kind of like, cringe every time I have to write, a basic CRUD API. It's like, I've been doing this for how many years, what my life is going to be. So it simplifies that and is a much easier way to implement. The Jakarta servlet specification allows the control of status codes and response body when sending a redirect. Run by that one. Added first with attributes error dispatches. Added finally constants for HTTP status codes, and added overloaded methods that use the char set rather than just a string. So a bunch of minor enhancements in Jakarta servlets 1. So other changes in the platform were Java SE graphic support, validation. The managed bean is finally deprecated. Security manager, as I mentioned, is being removed. On CDE, priority was added for producers, and JSON merge attached with that HRS. And moving into Jakarta EE 12, and this is where the community, as the Java users group get involved. There's many different things that could go into Jakarta 12, which is defined right now. The slides I'm going to go over show you some of the proposed features or what could be added. So the first one is Jakarta messaging. So this Jakarta messaging hasn't been updated in a while since the 2.0 release. Any major changes to it. So basically, talking about doing a more CDI-based modernized message listener, enabling you to use it in a standalone application without writing a message to the bean. basically adding messaging for cloud native uses, standalone Bootstrap API so that you can start it up outside of it easily. And then, more importantly, which would be quite a bit of, which would be really nice to have would be AMQP support, which would enable interoperability with more of the cloud stuff like Microsoft Azure Service Bus, AWS, MQ, Google Cloud Hub type stuff. So that would bring kind of Jakarta, this part of Jakarta more into the cloud. So that's something that you've been wanting or would like to definitely do get involved in specifications on that. This is what we had kind of proposed in for the ambassadors that would be nice with. We have the message scope being with message listener, use JNS beans, and then being able to easily bootstrap it in an application. Jakarta MVC has been around for a number of years. It is a standard-based web framework. It has continued to evolve, and we'd really like to get this one into the platform. It's based upon Jakarta REST. I think very close when Oracle was in charge, they actually integrated. So this is a simple example here. It's control and model view controller type building applications. Jakarta NoSQL, this is another specification that we're hoping to push to finally get added into the platform. So it's a specification for accessing NoSQL databases, as I mentioned. It basically is doing the same thing as GPA does for relational databases, except for NoSQL databases. So Neo4j, favorites, CouchDB, MongoDB. So basically standardizing how you map and get information to databases. This is standalone right now, so you can actually use it. You don't have to wait for it to be integrated into the platform. You can actually download it and begin using it today. So it is, it has been implemented. So this is just a simple example here of a NoSQL example. Stored in the database. So this code you can actually use today. The other one, Jakarta configuration, this is pulling the microprofile configuration over into Jakarta because there's a real need in the platform for standardizing configuration. So this is a way of basically pulling in configuration into your Jakarta EE application. Hopefully not using system properties, which I still see many developers using, right, where you pass something to the container, sort of that XML, and this is basically standardizing it so you can inject your configuration into your application and pulling this. Right now, you can use microprofile, but we're trying to get this into the Jakarta platform. We'd also like to see enhancements to Jakarta batching, basically moving the job definition over to Java so you can do it with the XML. And there's many other ideas that we have for improving adding things to Jakarta as well. So there's, we're going to go over, there's the Jakarta EE tutorial that's up there for learning. Jakarta EE, just many Jakarta EE examples that the website. So there's many different ways of contributing. You can join the Jakarta EE ambassadors and we'll kind of guide you through how to contribute to the platform if needed. So they can actually get involved and help drive some of these changes. We're getting started with it. If you're new to Jakarta EE, we have a Jakarta EE starter page, which you pick which version of Jakarta EE you want, and which container you want to use, and or what type of runtime environment you want to use, and it generates you a nice Maven-based project that you can easily get a project, stand up a project with. I also, for this presentation, put together, because that one does not, the official one does not yet support Jakarta EE 11 because it's not out yet. I have a Jakarta EE 11 starter project that you can check out and to try out any of the features that I have in the slides here with the presentation. And then one kind of interesting tidbit as I was putting together this presentation, sometimes reading the specifications is hard and a little boring, right, when you're trying to figure out some of this new stuff that's coming up. So I would ask ChatGPT, if they explain to me like how to, I want to quickly create an example of something that was in the specs. So the interesting thing was that ChatGPT, the new one, is familiar with Jakarta EE 11. However, it will completely BS you and create just random code. So I asked it, in this case, for what was it, the in-memory identity store, for an example of that, trying to like piece together for the presentation today. And it coughed up some code. I pasted it into the IDE, and that just flagged it red. And then I went and looked, I imported the topical request. I went and looked at it. I don't know if it picked up some like intermediate conversation in there. But I had, there were sometimes I tried different examples, then went off and tried different examples. Sometimes it got it right, and sometimes it just made stuff up and hallucinated, here's some code to try. So, but it is aware of Jakarta EE 11, which I thought was interesting, and make some suggestions sometimes. So in summary, Jakarta EE 11 is almost here, and it has many important changes that we're checking out and upgrading. If you've already made the jump from Jakarta EE 8 to 10 to 9 or 10, this is a fairly easy jump. One of the key ways of, so important thing is to get involved now to help drive the features that we want to see. As I mentioned, the resume is probably full of these words, so it's important that these technologies continue to move forward and move forward in ways that we want it to. There's no longer a marketing group that's trying to determine the features. So resources, there's the Jakarta 1 live stream coming up December 3rd, which is a Jakarta conference, mailing lists, Twitters, and everything else. There's multiple ways to find out information. It's pretty good. Jakarta 1, the Jakarta organization, the Group Foundation has a pretty good YouTube channel with different videos on different things that are coming up. So with that, thank you. If anyone has any questions.
So we're going on to a break now, so we'll be back in a minute at 3 o'clock, kicking off with our next session. Thanks, everyone.
a list of questions, and it's like, once for that, it's like, what's the most unethical thing about the time at work?
I'm not answering that.
Yeah. So, yeah. So, open
You should
show.
have that lying in at the interview.
Okay. When I was doing interviews, I was like fascinated. There was one company where I dropped the services after
Uh-huh.
it was
that good, huh?
It was Vine, which because I had Vine just about 10 years ago, so I had Vine. And like I was having great problems where I could dial somebody across the other 50 miles away, dial the pizza place down the street. The call would go
That's the
through.
place we need to call.
Yeah, so I could like, I was like infuriated, but it was like based upon like, I'm in front of me. They said, and we were looking through the description, I said, what are you doing? This is one, well, I'm responsible for encrypting. This is I'm responsible for encrypting all of passwords.
Huh?
Yeah. Encrypting
Well,
all
I'm like, I'm
passwords.
a dummy, and I'm like, what?
Yeah, so I said, what are you doing for that? They said, well, we're using base 64. I'm like, no.
You're not hired.
Like, no, that's not encrypting. It's not making sense. No, base 64 is not encrypting.
You're like, I don't even want to work here.
Yeah, it's just like, yeah, so it's like, no, it's like,
Okay. So many issues.
Oh, no.
it was
That's
like,
concerning.
oh god,
The
it was
report
like,
can be different every time.
You're like, you work here? I don't want to be here.
it's like there was so much stuff that was going on. Oh my god.
Die over me.
And there were people that were all like, flights and we were just like fishing.
Just like, how do you work here?
I'm like worried about like, do I know enough? We have one guy that we had like a series of questions. He says just to let you know, he says, I don't think it's out of
How does that even work, man?
I don't fix anything. I just like, okay.
You're not gonna be hired. Wow. People are crazy. Yeah, just, I don't know. Yeah, yeah, I had a feeling it was going to
Yeah, I was originally going to drive. Just cheaper. Then I punched it in. I was like, punched it in. I punched it in the thing yesterday morning for like I was going to run. I punched it in. It was 8.5 hours. It's like, okay,
Yeah.
great.
So my like same thing is awesome. Still to this day, like we have to do like medicine work part of the job. Yeah, it's like there was like goes down to the
Yeah, well, our head.
long drive.
Yeah, but I was like, trying to figure
Oh
out
yeah, the tunnel or the bridge?
or which lane am I supposed to do? Like, hang out in the car and it tells me like you made a wrong turn or
Oh yeah.
where you like end up on the wrong
You have
highway
to
or
pull
something.
over and map out.
Yeah, but that's, yeah, is our head
All right, everyone. We're about to kick off our last block of sessions. So, hands, sit down, get excited. Try to put some energy in here. Come on, guys. All right. So, up next, we've got Sujit, who's coming to us from a little town of Richmond, which is pretty close, and we're super pumped that you came all the way here with us for today. So, without further ado, I'll let you take it away.
Great, thank you. I know it's been a long day, a lot of great talks. So I do hope that you guys can take something away from this talk as well. I want to get right into this. So who am I? I'm a lead consultant at Toronto right now, but I've pretty much done software development for my career, especially with Java. I find the Java ecosystem with Spring and Jakarta EE to be more than enough for all the type of work that I do. Also a great supporter of anything free and open source. Definitely like anything that I can find in the open source domain, I like to get on with that. The most important thing for me though is delivering quality software. And just as equally, if not more, I want to do that without burning out my team. Obviously, there's a lot of, there's a lot of stereotype about developers and also about software development work in general. But what I really want myself and my teams to do at the end of the day is like go home happy and the next day like be really excited to come back to work and deliver great software. So that's kind of been something that I really like to focus on. So for those of you who already know about Java, this is a little bit of a refresher for those who don't. So Java has been around for 28 years. In the past, it has typically been like new releases would come out every few years, a big bang of features in each release, but then it would be silent for a long time before the next release. But at the same time, there's a lot of mature open source tooling that has been available for Java since the very early days. We talk about build tools like Maven and Gradle, build servers like Jenkins, and obviously the IDEs. You probably all have touched Eclipse. Also NetBeans is still around. But what has been happening in the broader software world, say in the last 15 years or so? A lot of new languages are becoming available, especially in the backend space with Node.js and Go that have kind of become like big over the last few years. Obviously, Rust is joined the group as well, even though it's mostly focused at the system programming level. Also, like from architecture perspective, we are looking at microservices, cloud native, functional programming. All these things have become more prominent over the last few years. Also, like things like distributed version control with Git, or CI/CD, containers, semantic versioning. So these practices are pretty much established at table stakes for the most part right now. And I would also say that from a people side, we have seen the open source community just kind of explode, especially with GitHub becoming this de facto open source source forge. Also, like there's been focus on the developer experience side of things. So yes, the languages are great, the processes are great, but also like how the developers do their work every day is also becoming an important theme for modern software development. So with all that happening, and Java being this slow, conservative way of releasing software, new releases, it kind of didn't feel quite like Java was hanging with the times. And about around around that 2017, Java 9 release, everything changed. So now Java releases every 6 months. So from March and September, pretty much every year there's a new release of Java. It has some features. It's not the big bang releases of the past, but it has some new features, some experimental features. And this has allowed it to kind of like catch up to the rest of the newer paradigms that are being propagated by the other languages, right? So things that we would never have expected to see in Java are now becoming more and more possible. And if you had attended the talk earlier by Chandra and Rodrigo, they kind of went through some of the new features that Java is bringing to us. But then there's also been some developer quality of life improvements that Java has brought into the picture. So there's a repo called JShell. Now we can actually run Java files without compiling them. You don't have to do Java C and then Java, then the class file. You don't have to do that anymore. And also the language is being simplified. So that was the talk from earlier today. A lot of cool stuff that they showed, they demoed during that talk. So with all that said, okay, the language is improving, but like overall the developer focus, developer experience focus has been overall to try to reduce the friction and the roadwork involved in software development. So what do I mean by that? So, and we actually had a talk like earlier about developer productivity engineering. So he covered some of these aspects of that, right? So there's a lot of like work that goes around just like getting your software built and deployed, and like anything that helps automate or at least reduce the chore involved is always welcome. So from open source world, we have things like ESLint, Husky, that help us with like doing some of the things that we would have to manually do. And then even some of the language ecosystems like Go and Node are providing some tools that are purely quality of life improvements. Like Go FMP is like a formatter that Go provides, NPM obviously from Node. But what about Java? So we talked about Java having new features, new language features, but what about the developer experience focused tools? So we obviously have Maven and Gradle, which have a plethora of plugins that help make our lives easier. We can also use the generic tools, the non-language specific tools like Husky in our development process. But what about core Java itself? Unfortunately, there is progress being made as we attributed to, but the real kind of solutions or the real world solutions are actually coming from the open source community. Some of it is innovation, some of it is imitation, meaning like we are looking at what the other ecosystems are doing, and we are just like adopting those. So this talk is about like 4 of those tools that are Java aligned but not provided by the core Java development. And we are going to try to look at this from an angle of if you are a completely new team that is building a Java application, what are the different stages you go through and what are the tools that are available for that. All right, so if you're a beginner in Java, it's, you probably remember back to the days like, you first have to set up a JDK, and you get this JDK to choose how to install it on my machine. And then you need a way, obviously, to write and edit the code. You use IDEs for that. But what about building and running the program? If you're a complete beginner, it can be confusing and like a lot of friction there. Obviously, we talked about the Java language syntax itself, which can be a little bit too much, and when you're trying to learn the language. And this is where this tool called JBang comes into the picture. So it was originally built to kind of build and run Java or JShell scripts and Java packages. So basically, like to take away all the ceremony around what it takes to build that Java source, and to just be able to just execute it like a Python program or a Java or a Node program. That was what the tool was aimed at doing. But it slowly started adding more features. So one of the first things it does when you try to install it is it tries to see if you have Java on your system. And if you don't, it will automatically download JDK and install it for you. Similarly, when you try to edit the code, it will check to see if you have, actually it doesn't check, it will ask you, do you have a code, do you have an IDE to do it? If you don't, it can download VS Code, Java support enabled, and you can use that. So this kind of takes care of a couple of things that beginners run into, which is not having the JDK or not knowing what tool to use to edit the code. And how does this work? So if you had a hello world.java source file sitting in your directory, you can just do jbang hello world.java and it will just run. You would compile it and it will just run. And if you build the source file with jbang, then you can even execute it directly as an, just as an executable. It has executable permissions on it right away, and you can just execute it. Furthermore, like what jbang does is it adds powerful scripting features to Java. So, for example, like you can pass in command line arguments or system properties directly to your source file. So you can just say jbang, something.java, and then pass in a bunch of parameters, and it will just like pass those into the code and process it. So in this way, it kind of exceeds what you can do with the JShell repo, right? And then another really cool feature, which is what really turned me on to jbang, is that you can use dependencies in your source code. So you can just put this line here which says / /deps and put the Maven coordinates of the dependency that you want, and then just import and use it just as regular. No need for Maven, no need for Gradle. You can just it will put it in your class path and make it available to your code. So in this way, it surpasses the Java 11 ability to basically run the files, source files directly, because it also allows you to import dependencies. And finally, we talked about being able to run jars. So yeah, so if you have a jar sitting in your local, or you downloaded a jar, you can just say jbang hello world.jar and you will execute it. But what is even more cool, again, is you can actually specify the Maven coordinates to a jar in Maven Central or wherever you have your artifacts, your packages, and then you can actually download it, resolve it, and execute it on your local. And if you need to specify a main method, there is a main main option to specify the main. So what does this do? So the really cool thing here now is that you can actually play around with any libraries or APIs that are available on Maven Central or anywhere else, and just play around with them without having to go through all the steps of writing code and creating Maven form.xml and all that stuff. Well, that's not all. So another cool feature is you can actually run Java source files that are posted in any URLs, right? So you're primarily talking about things like GitHub, GitHub Gist, GitLab, Bitbucket. So you have a source file there, and you can actually just say jbang URL to that source file. And what jbang does is it will parse through the HTML and just pull just the Java source out of it and execute it on your machine. Obviously, you don't want to run untrusted code from the internet. So it won't, at the first time you try it, it won't allow you to execute it. But once you mark the code as, or once you mark the URL as being trusted, then it will allow you to run it either once or like, for several other times, depending on which option you choose. So this is again really cool because you see, you want to share code snippets with your coworkers or like with anybody else. Like if they have JBank, you just need to provide them the URL and they can just do it without any setup. Another feature that I really like is that you can install the source files as apps on your system. So basically, JBank will like add it to your path and like make it available. So any shell that you open, you can basically just type the name of the file. In this case, like you say, okay, install hello world.java. Now you open any shell or any terminal, hello world is available to run. And then you can list all the JBank apps that are available and uninstall them. So what this helps with really is automation. So you can you can combine the three previous features that we talked about. Like you can host stuff with URLs, and like you can, like install them locally as jars. You can also like install them as apps on your system. Like all this helps with just being able to automate your workflows. If you're setting up CI/CD, you can use JBank to basically like provide the build tools that you need or build scripts you need. And you can write it all in Java. You don't need to do Python, you don't need to do Bash. You can just write stuff in Java and like use it everywhere. All you need is to be able to install JBank on your target machine. So just a couple of technical things. So JBank, there is some IDE support from such handful of IDEs. The way it works is JBank inserts this line. You see the / user something, and basically the / just like is a comment, and so ignored by the IDEs. Then you can edit the Java code. Whereas if you use the shebang notation, which is what Java 10 supports, then the IDEs will complain and they won't, then you cannot edit the code or do anything with IDEs. So this is a trick that JBank creator found from Go. Also we have Maven and Gradle plugins, so you can actually write, invoke JBank scripts from within Maven and Gradle. So again, just a quick, covered some of this already, but the idea is that this provides a way to not just create and run scripts, but you can also share it. And you can also share it with non-technical people. If you write some code in Java that you want to share with somebody who's not a technical person, as long as they can get JBank on their system, they can run it. And also it's a cool way for students and educators, if you're trying to run a workshop or you're trying to teach some high school students about Java, you can get them started very quickly. So that's with the initial learning Java, getting started with Java. But once you start working on Java, on multiple projects, right? So one of the common things you run into is hey, this program or this application uses Java 8. This application has features that are Java 17. This application has Java 11. And so then you can run into this problem. How do I install all these versions? How do I switch between them when I'm executing different projects? Or when you're basically even editing different projects, or when you're just working with different projects, how do you manage all that? And the Python and Ruby and Node, they have solved the problem with things like VME and NVM. So why doesn't Java have an option? Actually, we do, and that is called SDK-man. So SDK-man provides the CLI, which is very similar. It's inspired by all these other tools that we talked about, including apt and pip, and it just is a very easy and intuitive way to manage different SDKs on your machine. Um, so how it works, like for example, after you have installed it, if you just say SDK list Java, it will show you all the vendors that it supports, and there are a ton of them. Pratik was here earlier talking about Azure systems, but so that they also provide the JDK to SDK man, but there are also the more common ones like Eclipse, Oracle, Amazon, like all those JDKs are available from SDK. And then similarly, like even within each vendor, they provide multiple versions of Java, like 80 to 23 and beyond. So you can specify like install Java 17.0.13, and this TM is for Cameron, which is the Eclipse JDK. So you can just install very specific versions of Java and for specific vendors. And you can do this many times. Right? You can install as many as you want, as long as it's available on SDK man. I have noticed that sometimes they deprecate older versions, so you may not always find Java 8 everywhere, but like at least with the newer versions, you'll always find it. And you can install it and like manage it all through SDK. And you can set a default. So if you have several JDKs, then you always want to have your shells open with a specific version of Java, then like set the default. Say SDK default Java, and then 23, and then everything will be Java 23. But now if you wanted to switch back to a different version of Java for your current shell, then you just say SDK use Java 17 in this case, and you will switch back to version 17. But if you open a new shell, it will go back to 23. So clearly, like this is a very simple and easy way to manage the different JDKs. You can also uninstall JDKs if you don't need them anymore. But then one of the challenges is you have to remember, okay, this project uses this Java, this version, and like it can become like painful after a while. So how can we like pin a particular version of Java to a particular project, and or a particular version of JDK to a particular project? That's where we use this EMV feature. So if you set the Java using SDK use Java version, and then you say SDK EMV init, it will create this file called SDK-RC, and that pins the version of Java that goes with that project. And then you can just check it into your Git repo. So the next time anyone downloads, they will have SDK-RC, and all they have to do is SDK EMV install. If they have SDK-man on their system, it will automatically initialize and install that specific version of Java. But there's more than just Java JDK available with SDK-man. Right? So we also have a plethora of other SDKs available. So Scala, Kotlin, Groovy, all the JVM languages, mutual closure is there as well. If you want to install Gradle or Maven, like you can install it through SDK. And similarly, like if you wanted Spring Boot, Rails, Vertex, Spark, any of the frameworks, they are available through SDK. And then finally, like even the other tools we are talking about in this presentation, JBank, JReleaser, they're all available through SDK. So it can be your one source to manage everything Java on your laptop. All you need is SDK, and it's a very simple API. Right. I'm kind of going through it really quickly because I'm trying to get through all this stuff. But please feel free to catch up with me later if you have more questions. So once you get into the kind of active flow for developing an application, there's a lot of other things other than just writing the code, right? So there's like, your team has a Git workflow that you have to maintain or have to adhere to. There's all kinds of CI/CD pipelines that have their own requirements about how you check in code and where different things get built and deployed. There's also this whole like versioning aspect when it especially comes to like releasing code into your production environments. And there's the whole semantic versioning concept, major, minor, patch, that's kind of become the de facto standard. And obviously that doesn't work with the Maven conventions that were established a long time ago. So how do you manage all that? And it can become really painful if you're doing it manually. And that's where this plugin called JGitWork comes into play. So what JGitWork is it basically goes through your Git history and computes the version, semantic version, on like every time you basically run JGitWork. So it doesn't have to rely on any manual intervention. It can compute. And because of that, your project history is very clean. Especially if you have worked with this Maven release in your pipelines and you know how much chunk commits it creates. And then when you try to merge it back into your master, it creates another set of issues. So all that is gone. Like you have complete clean CI if you use JGit. The main concept that JGitWork uses is basically like annotated tags and lightweight tags. So if you use a Git annotated tag, right, so Git tag -a1.0, that is considered a major version. So you annotate, so once you are ready to release a major version, that's how you would do it. You would put an annotated tag, and then JGitWork knows that you're now pumping up to the next major version. Similarly, if you use a lightweight tag, like in this case, just say Git tag 1.1, it knows that now you are basically like in a minor version, which is a non-breaking change. So just with these two actions, you can basically like control the versioning, and then JGitWork will always consistently calculate the correct version based on the Git history. So again, like there is a Maven extension. You just need to add it to your extensions.xml, and whenever you want to compute the version, this step Maven validate will basically do the computation. Similarly, Gradle has a plugin, and if you run Gradle version, again this will like compute based on the Git history. Now the JGitWork supports like 3 different modes, or like basically it has this thing called a Maven mode, Gradle mode, and a custom mode. So basically those are conventions about the Maven convention and then the Gradle convention about release versioning. So you can indicate what strategy you want to use. Whereas if you use the Maven plugin, it will automatically default to the Maven mode. And this basically shows you like how it works, and we just kind of covered that. But the main thing I want to point out in this picture is if you create a branch out of the master, it will actually add the branch name into the version. And this is really helpful because if you have one person in your team working away on on a bug somewhere, and you start working on a different bug, but you are just both of you are branching off of this of the minor version, then when you would both basically end up calculating the same version. When you try to merge back things in, it becomes a mess. So by adding the branch name, it will basically make sure there are no conflicts between the version numbers. I thought that was a very clever way of handling that scenario. Similarly, it does this very similar thing with Gradle, obviously without the snapshot of the release. All right, so we have 2 more minutes. I'm going to run through the last thing here. So the last thing is once you have gone through all this, like you set up your machine, you set up your JDKs, you've been developing your code, and you finally want to release it, especially if you're doing something like a library or a framework, something like that, then there's a bunch of chores when it comes to rolling stuff out, right? You have to create the release, you have to create the distribution artifacts, and you may want to announce it in different mediums. So there's a lot of like chores around that. And that is where JReleaser helps with JReleaser basically automates all of that, right? It's inspired by this tool called Go Releaser. But basically what it does is it creates Git releases, publishes your artifacts to multiple package managers, and it also announces releases. So what does that all look like? So this is basically what it looks like. So your build tools will generate the artifacts for your release, and then JReleaser uses that to build the release for the Git releases, like you can do GitHub, GitLab, etc. You can package and make it available to your different package managers, and you can also announce, through different media. So the integrations, they support a lot more, but an example here is GitHub, GitLab, Codebird. It can create those releases. If you go to GitHub repos, you see those releases. You can build that. Similarly, you can publish to App Image, Flatpak, Snap, even to Docker. You can basically publish those to those package managers. And similarly, like you can announce to Slack, through Slack, through Teams, LinkedIn, like whatever medium, if you want to announce the release of your software, you can do it. And all this is done by just configuration, right? So if you use the CLI, there's a JReleaser.yaml file or toml, JSON, whatever format you want. Or if you use the plugins for Maven, you can configure it in the POM or Gradle in the build.gradle. And ultimately, you can also use this in your CI/CD platform that supports things like GitHub Actions, Jenkins, CI, etc. So to wrap up, there are a lot of open source tools available in the Java for Java developer experience. So please look into these, try to use them. They're all very easy to use. Contribute back where possible, and and always be learning from other ecosystems. We need to take the good things from the other languages, bring it back into Java, so Java can always stay in touch with the rest of the world, right? These are the tools we talked about. The links to their pages, and this is a contact info for me if you want to talk to me catch up with me later. That's it. And if you have questions, please reach out to me afterwards and one of the other speakers. So thank you all.
All right, big round of applause for Sudhir and Paul. Thank you. There's a lot of people taking notes, so make sure if you do have questions, you reach out to Sudhir. He'll be around, so he can answer all of the questions you have. So up next, we have our last speaker, and that would be Vikas Grover. You in the house? Oh, perfect. You're here. So up next is actually supercharging business with generative AI, something we're all talking about lately. Boosting accuracy with dynamic information retrieval, which will include a live demo, I believe, which I'm pretty excited about. 'Cause that's where the magic happens, right?
You guys hear me okay? Okay, thank you so much, guys. I think I'm the last speaker, so I'm not gonna hold you back for very long for a happy hour that's coming right after this one. Thank you for staying. I am local here, based in Northern Virginia. So, yeah, last time I was presenting at some local conference, and that's where I met. So he suggested I should come present at this conference. Once again, thank you so much. That's my book right there that I published last year. This was about hybrid cloud. So essentially taking your applications and not getting tied into one or two or any single cloud for that matter, but writing your apps in a way that you can move them around whenever you want, wherever you want, so that you feel in control of your own code that you have wrote to serve your business. Having said that, I'm going to do some level set. First of all, what is AI? Maybe right now, right after ChatGPT came, everybody knows what AI is, right? Artificial intelligence. Everybody is talking about it. There is a lot of buzz about it. It's not like AI is a new thing, but definitely right after ChatGPT, it's everybody's thing. Like starting from school kids to all the way to any organization, any business for that matter. I think there's a big prediction out there from Gartner how Gen AI, especially the ChatGPT was basically Gen AI, right? Generative AI, and that's what created the whole huge buzz. And a big prediction from Gartner is how more than 80% of enterprises will be using Gen AI capabilities. So we will see what Gen AI means, but I want to do some level set here, right? So like I said, AI has been around. There was predictive AI, but then came the Gen AI. So we're not going to go through all these line items, but essentially what that means is Gen AI is about generating new content, and that's what created the big buzz. Predictive AI was analyzing the data and look for certain patterns. But Gen AI is essentially, like I said, generating a new stuff from its own creativity. So, a rapidly growing area, and you have all heard of LLMs, which I'm going to just talk about. But from predictive AI to Gen AI is where we are trying to move towards, and everybody is talking about investing in this particular area. So, like I said, I'm going to do a level set, and then we're going to head on to the topic of the day. But AI has been around. We heard about that. Machine learning is a form of AI, and Gen AI which came in. So what made Gen AI possible was our foundation models, or foundation models, right? What does a foundation model mean? These are general purpose models that are trained on huge quantities of data, and then they serve you the answer. So if people who were in that room earlier, they saw a lot of examples. One of that example was when you keep asking questions, same question being asked to ChatGPT does not guarantee you same answer back. It will respond you different answers, and sometimes even incorrect answers. So you cannot rely completely on ChatGPT or a foundation model as an instance, because foundation models are non-deterministic. It means that they do not guarantee the same answer, even though you may be asking the same question again and again, using ChatGPT or whatever model you are having. So keep that in mind. Now LLM is so we have a so what companies are doing then, they're training these models on their specific data, right? Keep on training them to make sure that the outcome of the model is pretty precise or accurate to a great extent. And now let's look at that. I'm going to jump to this part, right? So now, when you have a model, you want to train that model so that you can get a business outcome. This is the very important part we gotta understand. There are different ways to tune or train your model, and the complexity increases based on what technique you end up using, right? So you, like I said, you have ChatGPT today, which you are the most familiar with. It has, it's using the underlying model, which has been trained on a lot of public data up to a certain time. After that time, it has no knowledge about what happened, which means that if you ask the question, the response may be incorrect or totally irrelevant. It will continue to keep responding to hallucinations, right? You keep giving you incorrect information. So essentially what you're then trying to do is you're trying to apply different techniques to train that model to fit your particular use case. So as an organization or as an individual or a research scientist, you may be taking that open source model, right? Bring it in your own environment and you say, okay, this model has been trained on certain public data up to a certain point, but I want to take this model as my baseline and I want to work on it, train it to fulfill my particular use case. What technique would you like to use, right? And that's what I'm trying to kind of showcase on a high level here. For example, there are 4 different ways written here. If you see the rightmost, which is built from scratch, you absolutely could build from scratch rather than taking a model from open source community, but that would be very complex, very expensive process to do it, and it can cost multi-millions of dollars and a lot of time. So maybe that's not something you want to do. Fine tuning could be another technique, which would again be very expensive, time consuming. Quality of that would be better, of course. But once again, expensive, right? So depending on the use case, it may be appropriate for you. You may be using some other tuning techniques, like prompt tuning as well, right? You prompt it in a certain way by doing prompt engineering, that your output starts to come out to you. Now, RAG is a technique that we are talking about today. So what essentially RAG means? RAG means that retrieval augmented generation. This is the subject of the day. So essentially what that means is, think of it like you are going to give data to your model, but that particular data will not change the underlying model. It will not change the DNA of the model. It will just augment it. So think of it as a trailer you will be hooking behind the truck. So truck stays the same, but now you have additional load carrier sitting behind you, and you can of course unhook it and hook something else, or you can hook a bigger trailer. Just think of it the way you would like. The point being, very fast, very effective, and essentially cost. There is not much cost to that as well, and the outcome will be very precise. The reason that it would be very precise is because it's augmentation. So you have a model. Earlier what you are doing is you are feeding a data to the model to train it, right? You are trying to change the DNA of the model. So it's very expensive, time consuming, and then you will see the output, and then you will realize, oops, maybe it's working, maybe it's not working. So you got to do that job again, you got to train it again. Now how about I tell you this thing? You have a model, and rather than training the model on all this different data, why don't you feed about your, as an example, company financial information, which is written in those 10K documents, which you filed with SEC for last 25 years. Now that information is already documented, right? So you just attach those documents with the model, right? And then essentially what is happening, whenever somebody asks a question, model will say, okay, I know I need to look into these documents, and I can pull pretty precise information from the document and give it back to you. So more or less like, it's search and query. And that is what makes it cost effective, precise, and super effective. So there are a lot of business benefits to that. It will improve your search relevance. It will help you with personalized recommendation. recommendations, you can create content. Also, by the way, for example, you can even do it on ChatGPT as an example. If you go to ChatGPT, there is a way to upload a document somewhere, I believe. Oh, here it is. Attach file, connect to Google Drive, upload from computer. You can even upload a document as an example here. For example, I'm uploading this particular document right now in front of you, and essentially I'm feeding my own document. It looks like you uploaded a blah blah file. How would you like to proceed? So you can imagine that the model has been fed this particular very specific document, and whatever question I will ask, it will go and read in the document and give its analysis on it. So this is one way that you can you can realize the potential of it. Going back to my slides, how does this process work in enterprise or complex use case? Because when you're working in a healthcare company or when you're working in a financial institution, you are not going to use ChatGPT, right? You probably will be prohibited to do that, and you are not going to be allowed to upload your financial documents or patient-related clinical data on ChatGPT, because then you will once again be in trouble. So you will be having your own model, and on that model you will be uploading your own company documents or your proprietary information or whatever that might be. How would that work essentially? You will load your data. It's like 3 or 4 step process. Load your data, so you're loading or uploading your document. What that does is then it splits those documents into smaller chunks and then stores and index those splits for better search criteria. So it uses a vector store. So think of like you can even use Postgres database. That's where it stores all these chunks of data, and you then come in and start to do search or ask questions. So basically, retrieval of that information will start to happen. So you will ask a question, and like I said, the LLM will say, okay, I'm supposed to, the question has been asked to me, and I'm supposed to also see in the vector database if I already have an answer to this question, and very likely you will get pretty relevant, precise answer. And what does that mean? I will also tell you. So, let me just jump in the code. So, what we are looking here is, as an example, a Python file which is for you as a data scientist. And remember, there were 4-step process. You load your document, you then split a document, you then store the document in smaller chunks, and then later you do retrieval on those documents. So essentially those 4 steps happen. And in the meantime, the indexing of that information also happens. So obviously, like anything in technology, there is always a trade-off. Just because you uploaded a document and it's going to read and process it, also depends on how great of an indexing happening or for better search. That's one part of it. Second part is when we are uploading these documents, how the format of the document was like, because if it's a text format, it's easy for the model to consume it, ingest it, store it, or if there's a lot of tables, a lot of images and stuff like that in a document, so things will start to vary based on the content. That has been my experience. So I'm just going to show you very quickly what is happening in this particular Python file as an example. So obviously, there are certain libraries that you see here, LangChain and whatnot. That's all fine, right? The real magic starts to happen right here. So for example, documents. So I'm trying to upload here multiple documents. These notes, whatever the headline of a particular document is, you can mention it here. You can mention, where is the location of those documents, the URL of those PDF files or Word documents. You can just mention them here. Once you run, run this particular piece of code, you're loading those PDFs. Further, you are storing them in this particular folder here, which they get created right here once you run or execute this piece of code. And you also give reference to additional information. So for example, you have this particular document and you may have your own company URLs. You may want to give URL to URL link of those documents right here in the notebook as well. So basically you're just giving extra references. And then ultimately, remember, we load the document. So we have done that particular task right there. And after that, what we do is we merge the PDF doc and the website doc, which is kind of a good exercise we're trying to do. Later you do splitting. You split those documents in small chunks for storage, and you then start to create the index on it, so there is a better search or a relevant search that starts to happen. So you're doing all of this thing in your Python notebook, and after that you do your test query to see how the result looks like. So I'm just gonna do one small example for you just to showcase you. Run my notebook basically, right? This requirement is already satisfied. Further, I continue to load additional libraries of LangChain framework. Then I go ahead and load a particular, for example, I'm gonna delete this folder right now. Right? So now if you see, I have a model, right? Whatever Llama, Mistral, whatever you are using, and on top of that, I have I'm working on this particular Python file to implement RAG technique by bringing in additional document, and I'm trying to upload this document. So I have given the path, and I run my path, and in few seconds we will go ahead and here you go, the folder just got created, and then the PDF also was uploaded in my Python file, right? So that happened. So I have done my ingestion. I have ingested the metadata. I have also loaded, some additional information from public URL or a website. And then now that my document is ready, I'm going to do the splitting of the document for better search technique, because if you remember from the last slide, there are 4 parts to load, split, embed, and store. So we are doing that in this piece of code. Splitting happened, some cleanup, some additional housekeeping techniques, and then we are also doing embedding of the data, and ultimately we reach to the last stage, which is run the query. Okay, so what happens once you upload the document, it takes quite some time to do splitting and indexing of it. The results don't come immediately after. However, this is how the process works. As you can see here, you can also do some testing within the code itself. So for example, it starts to show you scores like 0.99, and this is a very good score when you ask a question. So, this is one of the examples, but in the meantime, let me show you something. So, this is a window where RAG technique has been applied to the chat part. This is the window where there is no RAG technique has been applied to the chat part. Now, if you see here, when I ask the question, what is the latest version of, OpenShift AI self-managed, the known RAG version says, I don't know what you're talking about, in so many words, that's what it says. But when you go to the RAG version where document has been fed, and you run the same question, it says, okay, so this is what happens, right? Earlier it was giving me an answer based on the context provided, blah, blah, blah. These are the 2 documents that you have uploaded. This is the answer. So, like it happens in, when we are doing demos and stuff, indexing breaks. But my point being, as it, we keep on doing experiments and stuff, so don't worry about that part. Essentially, with the RAG technique, you are uploading any documents that you want, and you are making your LLM models more intelligent and more precise. And it is very cost effective, and you can basically make your models effective on in a very short time frame, and reduce the hallucinations. So, any questions? This is how the architecture of this looks like. And I think one additional thing I would also like to highlight, as you see more and more organizations or people are implementing GenAI, trying to implement GenAI, but you will see that to make them more effective, to solve their real life use cases, the very first thing they are implementing is RAG technique, because that is the most effective technique for them to make something useful out of it, rather than relying on some model that has been trained on certain data which may not be even giving a correct output. RAG is creating a immediate impact. So very important, very valuable technique. So the key takeaway for you is, when you think about, I want to do something with GenAI, I want to make an impact, the very first thing you should learn is how can I implement RAG with GenAI so that I can produce something of value which doesn't hallucinate and it is also possible. Alright? Thank you so much. Any questions? Just let me know.
Any questions? I think I got it too. So it's load, split, store,
Yes, sir.
retrieval.
That's right.
Oh, look at me go. I was there today. All right, any questions? All right. Well, thank you so much, Vikras. Thank you so much to everybody who stayed with us all day. I know it's been a long day, but there's been so much good information. As I mentioned before, we do have a happy hour. It's happening at 4:30 at Spider Kelly. So it's a couple blocks away, but we'll have a bunch of our speakers there, and also mingle with some of the other attendees. So hopefully I see you there. Thanks, guys.